Hi guys, this is just another quick video, part 2 of the drawing text. So I'll just run through the code. This is courtesy of Milton W, by the way. He's I've been in touch with him and he showed me the light on using the data and a loop here. It's really cool code actually, it's great. So here we go, the normal stuff, just setting the screen mode, getting rid of the cursor, clearing text and graphics in case there's anything on the screen. That's setting the colour for the graphics. Screen width and height, apparently in basic they stay the same. It doesn't matter what screen mode, they're like a graphical unit rather than a pixel or anything. So it's always 1280 by 1024 whilst in basic. That's from my understanding anyway. The scale, we've got no scale factor or anything on here. We're just scaling a static picture, so scale. I've just picked a number that fits the screen well. Right, and then we've got our starting off coordinates for the drawing. Obviously wherever these coordinates are on the screen is where the drawing starts, the bottom left corner of the image that we're drawing. So dx is the default x and the default y. Default x equals screen width divided by 2, so that's the centre, and then minus 32 because that's 2 of our 16 by 16 characters that we've used on this. And then that times as a scale, so it doesn't matter what the scale is, that will keep it central. And then all we do is we proc draw, we call the draw process, and then once that's finished we end the program. Here's the draw process. So we define an array here. Now this array, I was under the assumption that it had to be the exact size for the data that you're putting into it, but apparently it just needs to be big enough to hold the data. So we've just got a 1024 there. Now here's the repeat until loop. So obviously this just keeps going round until this condition is met. So we start off and we read the data and we put that into x and y, so it's getting two, it's doing it in chunks of 2, so we've got an x and a y and then an x and a y and then an x and a y and then an x and then a y. I've kept these in blocks of 16 just so that it keeps it neat and tidy. I'll go through these ones that have got the minuses in a second. So we've read them into x and y. If x is a positive number, if it's 0 or above, it goes down to line 1140, which is the draw function, 1140. So it draws. This bit of code here determines if we are drawing or moving, and this is where Milton W helped and supplied this code. So how that works is if x, so if, so say this number here, or here, or here, or here, obviously this is x and this is y, and then this is x and this is y. So if the x is greater than 0, i.e. all these numbers, it's going to draw dx, which we've got the default x there, plus x, which it gets from the data, times the scale, and then it's going to draw the default y plus the y that we get from the data, and then times that by the scale. And that's the draw function. So it will draw to those new coordinates from its last coordinates. And then we go down and end. Now, if it's not equal to 0 or above, which is obviously a negative number, then we obviously don't go down to 114. So then we go if x equals minus 1, 2, 3, 4, 5. This is just a special code so that we can go down to 115. That just skips the draw, ends the if, and then we'll get down to the until x equals minus 1, 2, 3, 4, 5. So then we're at this here, and that's so it loops until it gets that. So all we do is we put that at the end of our data statement. It doesn't matter how big this is, as long as it fits in the array, obviously, but it doesn't matter how big that is. We just make sure on the last line we do another data with that magic code, and that exits us out. That means we've finished drawing. So it's going to draw until it gets to that, or if it's a minus number, here we go. So if it's that, go down to that. If not, if it's a minus number, it's this. And we've already gone through, that's going to terminate it. If it's not that code and it's still a minus number, x is going to equal the ABS of x. So all ABS does is it converts a negative number to a positive number. So if we've got a negative 1, it's going to convert that to a 1. If we've got a negative 2, it's going to convert that to a 2. So these coordinates on that first loop, it's going to get down to here. It's going to hit minus 1 here. It's going to keep going, and then it's going to convert the minus 1 to 1 and convert the minus 2 to 2. And then it goes to the move. So then we've got the dx, which is the default x, plus x, which is now a positive number, times the scale. It's just the same as the draw, but now we're into move. So that minus number is a way of telling this loop that this data with a minus is actually a move command and not a draw command. Anything else, positive number or a 0, is a draw command. And that is basically how that works. Now, we do have a slight problem. There's one downside to doing it this way, but I'm not bothered. And that is if we want to move to an x0, so the bottom line of our imaginary box. If we wanted to do that, we obviously can't have a minus 0, so we can't actually move down to 0. But all I do, I'll show you in another example that I've done in a minute. All I do is convert all my coordinates and just add 1, so it keeps it. So any zeros, like here and here, any zeros then become 1s, and then we can move it to that location. It doesn't matter with this code if the y is a 0, because we're only checking on the x. But for the purpose of what I needed this for, it's absolutely brilliant, and I'll probably work out a way so that it can work and still include the zeros. But if I just run this, just so you can see it exactly what it does exactly the same as the other program, but it's doing it this different way. So I'll just run it. Where are we? What's it called? I need to save that. Demo draw. Right. So we'll CD into. Something wrong with this keyboard. CD into B. Load demo underscore 10 underscore draw text 2 dot bas. Just check that. Yep. Nope. Loads wrong. Oh, this keyboard keeps missing letters. Load demo 10 draw text 2 dot bas. That should be it. So there we go. Does exactly the same. It's exactly in the middle of the screen because of obviously how we did the dividing the screen width and height by 2, and then I did minus 8 pixels times the scale for the y-axis, and minus 32 pixels, because obviously this starts out on scale 1. Each one of these is 16 by 16, the same as my previous tutorial, and it's just a way of easily converting images with graph paper and such like, or GIMP image editing tool or whatever you use. It's a way of being able to do it so everything's within scale, and pixel perfect basically is doing it on that grid system, and then just move the default position, which is obviously, it would be in line with this, is 0 and 0 is here somewhere. So all these measurements are just taken from this. 1 in 2 up as the move, and then 1 6, 3 6, and so on all the way around. Now I just want to show you another little thing which I've been working on, which was Louis from Learn Argon, the great YouTube channel. He did, you can actually get it from his GitHub account, which if I'll link it in the description below. I'll link Louis' GitHub page, and he's got the original, he did all the work for this on the actual image. So what we've got is, oh dear, where are we? Desktop, Agon, emulator, SD card, B. What we've actually got is the exact same code as what you've just seen. The only difference is I've had to move the scale above the coordinates on the other variables, because I used the scale to get the dx and the dy on the other one, because obviously I'm scaling it to the centre of the screen. Apart from that, everything else is the same, the code, and it all works the same. And I've just converted Louis' code where he drew it, so these are all Louis' numbers, but I just added 1 to everything to get around that 0 problem, so there's no zeros in it. I added 1 to everything, and then I obviously converted all the move statements that Louis had into the minuses to give me that function of move. I've obviously put the end markers at the end, so it ends the program, or ends that repeat until loop. I think that's the only difference. I altered one figure here. This was 160 before. Don't know if that was my working out off Louis' original, or if Louis had a pixel or 2 out, but I've converted that from 160, which would have been 159 on Louis' code. Obviously I added 1, which made it 160, and it made it a little bit too long. It stuck out the back, so I've just shortened that back to 158, and I'll just run that for you now so you can see that, because thanks to Louis and Milton W, I've just put the code together basically. But thanks to those two, we have things like this. New. Right, so I'm still in B. I want load Ferrari Lewis dot bash, and we run that, and there's his car. That little bit of code that I was saying had a couple of pixels sticking out here. It may have been Louis' exhaust, and maybe he needed to add a couple more at the bottom just to make it a bit thicker, but it looked a bit odd with it sticking out, so I've just tweaked that. And I know Louis got this code already, and he's going to be tweaking the odd pixel here and there and adding bits, I'm sure. Maybe trying to get some round objects in these bits here, I don't know. But yeah, I just thought I'd share that, because that's pretty cool that they've a drawing like that just done through code like that. Hope you enjoyed this one. Thank you very much.